Hello, ladies and gentlemen. We're going to do Algebra 2, 7.5a, Properties of Logarithms. So just more work with our logs, learning to rewrite them in different ways. So let me do the properties first. There's not very many, and I guess I should tell you what our objectives are. We're going to rewrite expressions and evaluate them. So that's what we're going to do today. All right, the product property. So if I have the log base b of m times n, that can be rewritten as the log base b of m plus the log base b of n. Alrighty? So that would be my product property. So I can use it to rewrite. Later we'll use it to solve. My quotient property, which means division, is going to be the log base b of m divided by n, and I can split that up to be the log base b of m minus the log base b of n. Okay? And then our last property is called the power property. So if I have the log base b of m raised to the n, the exponent goes out front, and it's going to be n log base b of m. So we will use these pretty extensively as we rewrite and evaluate our logs, okay? All right, so let's do our first example. We're going to be given that the log base 4 of 3 is about 0.792, and we're going to be given that the log base 4 of 7 is approximately equal to 1.404. So I want to use the properties and my given to evaluate. All right, so as we do this math, the first one is going to be the log base 4 of 3 divided by 7, okay? So the first thing that I need to do is rewrite this. So this is the log base 4 of 3 minus the log base 4 of 7. Division is subtraction when I rewrite it. Well, I was given that value, and I know that it's 0.792, and I was given this value as 1.404. If I do that math, I get a negative 0.612, and that would be the solution. And I got there by using my properties, okay? The second problem would be the log base 4 of 21, and that's going to be rewritten again as, sorry, this one's not division. I could rewrite this as multiplication, so I'm going to write it like this, the log base 4 of 3 times 7, because 3 times 7 is 21, and I was given the log base 4 of 3 and the log base 4 of 7. Now I use my properties. Multiplication is addition when I rewrite it, so I'm going to do the log base 4 of 3 plus the log base 4 of 7, and then I get the 0.792 plus the 1.404. Simplify that math, and I get 2.196. Okay? So the properties allow us to evaluate logarithms. All right, and then my last example on this one would be the log base 4 of 49. Well, 49 is 7 squared. That's actually 4, by the way. So I could rewrite that as the log base 4 of 7 squared, okay? And if I do that math, the exponent goes out front, so I would get 2 log base 4 of 7. And I know this value, so that's going to be 2 times the 1.404. So my answer for this one would be 2.808. So we won't do many of these, but a few. And we just use these to help us evaluate our logarithms. So let me do one more example, same type of situation, just to be given different values, just so you can see a couple more examples. This time I'm going to be given the log base 6 of 5 is approximately equal to 0.898, and then I have the log base 6 of 8 is about 1.161. Okay, same directions as the last problem. Okay, so I'm going to have my first problem is the log base 6 of 40. Well, I know that 8 times 5 is 40, so I could write this as the log base 6 of 8 times 5. Okay, then I can use my properties. Multiplication is addition, so I would do the log base 6 of 8 plus the log base 6 of 5, and I'm going to get 1.161 added to 0.898, and I get that that answer is 2.059. All right, if I do the second problem, my second one is the log base 4 of 21. 21 is, oops, sorry, that was our last problem, my bad. This one is the log base 6 of 64. So if I rewrite that, 64 is 8 squared. Coffee's ready. And I could do the log base 6 of 8 squared. And I would take my exponent out front, so I would get 2 log base 6 of 8. Multiply that by the given value. And I would get that it equals 2.322. So much fun. All right, one more of these. If I do the log base 6 of 5 divided by 8, that's the division, so I do my quotient property. So that's going to be the log base 6 of 5 minus the log base 6 of 8. So I'm going to get 0.898 minus 1.161, and I get a negative 0.263. So that is the last example using those properties. All right, so now let's do properties to do what's called expand a statement. Okay, so we're going to do some examples now where I want to expand the statement. Okay, which means I want to use my properties of logarithms to make the statement a little bit easier to manage. All right, so we're doing a bunch of examples on this. So my first one, I'm going to have the log base 6 of 5x cubed over y. So that's a pretty complex statement, but if I use my properties, I can break it up. So I have 1, 2, 3, technically 4 different things going on. I have multiplication, which means I'm going to have addition. I have an exponent, which means that would go out front, and then I have division. So I'm going to do it in steps. I'm going to do the log base 6 of 5 plus the log base 6 of x cubed, and then I'm going to subtract the log base 6 of y. The only thing that I now need to simplify is that 3, because the power property says that it goes out front. So I'm going to have the log base 6 of 5 plus 3 log base 6 of x minus the log base 6 of y. And that is going to be your answer. So I took a very compact statement and I expanded it, which later we'll use to help us solve some log equations. All right, the next example, I'm going to have the log of 3x to the 4th. Remember, if they don't tell you the base, it's a common log. That means the base is 10, but I don't have to write it. Again, I have multiplication and a power, so those are my two things going on. I'll do it in steps. So I'm going to have the log of 3 plus the log of x to the 4th. I need to manage the exponent, so I'm going to do the log of 3 plus 4 log x, and then that's my final solution on that one. Alrighty, number 3. I have the log base 3 of the square root of 9x. So I actually need to rewrite this before I get started. So I'm going to rewrite this as the log base 3, 9x raised to the 1/2 power. Because remember, the 1/2 power is the same thing as taking the square root. So now I can split it up. I'm going to manage this first. So I'm going to write the 1/2 there. And then I'm going to do the log base 3 of 9x. Now I have a product that I need to manage. So I'm going to write this as 1/2 times the log base 3 of 9 plus the log base 3 of x. The last step, I'm going to distribute the half, and I get 1/2 log base 3 of 9 plus 1/2 log base 3 of x. And then this one's done. All right, so we took a compound statement in these three examples and made it bigger. Now we're going to go the other way. So now we're going to take a big statement and we're going to make it little. All right, so these are called condensing. Okay, so it's going to say use the properties of logs to condense a statement. All right, so first example, I have the natural log of 12 minus the natural log of 4. Now, the one thing that you do have to pay attention to is you can't condense a statement unless the bases are the same. Because if the bases are different, that creates a different type of problem. So, let's just, ooh, my coffee's creating a shadow. Let's move it out of the way. When I do division, I do it this way. I would write the natural log, because remember, if I have two things divided, I subtract, and then I draw a dividing line. The things that are positive go in the top, and then the minus things go in the bottom. I do need to simplify that. 4 goes into 12, so I could also simplify that to say the natural log of 3. All right, our next example. If I have 6 natural log x plus 4 natural log y, numbers out front are exponents, plus means multiply. So I'll do it in two different steps. First, I'll manage the exponents. So I'll have the natural log of x to the 6th plus the natural log of y to the 4th. Now I'll manage the multiplication. So this is going to be the natural log of x to the 6th, y to the 4th. That wasn't so bad. All right, now let's do one that's a little bit more entertaining. So let's say I have a 5 log base 4 of 2 plus 7 log base 4 of x plus 4 log base 4 of y. The first thing that I'm going to do is manage my three exponents. So I'm going to have the log base 4 of 2 to the 5th plus the log base 4 of x to the 7th plus the log base 4 of y to the 4th. So now I need to manage the multiplication. So I'm going to have, and 2 to the 5th, by the way, is 32, so I'm going to scratch that off and write a 32. So now I'm going to have the log base 4 of 32 times x to the 7 times y to the 4th. And then you could stop there. You could leave it like that, or you could rewrite it as the log base 4 of 32 x to the 7 y to the 4. So this would be my preference. Okay. Alrighty, I have one more of these. Okay, so let's do the log base 5 of 4 minus 1/3 the log base 5 of x minus the log base 5 of y. Okay, so again, I have one exponent, so I'll do that math first, and then we'll manage the division. So if I rewrite that, I'm going to get the log base 5 of 4 minus the log base 5 of x to the 1/3 minus the log base 5 of y. Now I need to manage the minus. When I do those, I'm going to write my log base 5, and then I'm going to draw a line. Anything that's positive, like this, goes in the top. Anything that's negative goes in the bottom. So here's going to be my 4. In the bottom, I'm going to have x to the 1/3, and in the bottom, I'm going to have y. So if I rewrite that, I have the log base 5 of 4 over x to the 1/3 y. And that would be my final answer. All right. The next concept that we're going to learn is a cool formula, and it's called the change of base formula. So a couple of you have been asking me, what do we do when we have numbers that we can't put in our calculator? Well, this is how you manage them. So remember, your calculator has a log button and a natural log button. This one is base 10, and this one is base E. But what if I have something like this, the log base 4 of 5? I can't do that in my calculator, but I can use the change of base formula to help me put that in my calculator. So let me show you what the change of base is. It says if I have a log with a base that's not 10 or e, I can rewrite this expression as the log of a over the log of c, which means I chose a common base for both of them, and this one I chose 10. I could also do this if I had chosen a base of e, so I could have done the natural log of a over the natural log of c. All right, so this is what allows me to get that in my calculator. So I'm not going to do this example because I don't have my calculator handy, but let's do another one, okay? So here's our first example using the change of base formula, okay? And I'm going to want to evaluate, which means I need to get an answer, okay? And I'm going to have the log base 3 of 8. I can't do that in my calculator, but I can do a change of base. So I can do the log of 8 divided by the log of 3. And if I did that math in my calculator, when you hit the log button, it opens a parentheses. You need to close it. And then you would divide by, open, close. You need to be very careful to close those parentheses. And if I do that, I would get 1.893. Well, I also want you to see if I had chosen e, if I did the natural log of 8 divided by the natural log of 3, you'll want to do it all in one step on your calculator, and I would get 1.893. Okay? Let me show you the steps to write it down. I would do the natural log, it's going to open a parentheses 8 divided by the natural log open, close, equals. Don't do this and write down a value, and then do this and write down a value, because you're making and generating a lot of error. All right, let me do a couple more change of base examples for you, and then I'll give you your problems. All right, so evaluate using the change of base. And I'm going to write change like that, change of base. Okay? All right, so the first one is going to be the log base 5 of 8. Okay? Since they've already used log, I'm just going to stick with the log. It really doesn't matter which you use, because you saw in the last example that I get the same answer either way. So on this one, I'll just do it with logs, and I would get 1.292. If you decided to do the natural log of 8 divided by the natural log of 5, you'd get the same answer. Okay? The second example is going to be the log of 8, base 8 of 14. And again, this time I'll start with the natural log, divide by the natural log of 8, and I would get 1.269, which would give me the same answer if I had done the log of 14 divided by the log of 8. So the change of base formula is actually a pretty slick little formula, because it allows you to solve things that your calculator is not programmed to do. All right, let me give you your problems. All right, number 1 says use, oops, that's an S, use that the log of 4 is equal to 0.602 and the log of 12 is equal to 1.079 to evaluate. And you also have to use your properties. So you have to use both things to be able to evaluate. So A, you're going to have the log of 48, B, the log of 64, and C, the log of 1/3. All right, number 2, okay, sorry you couldn't see those, it's going to say expand the expression using properties of logs. All right, A is going to be the natural log of 15x. Okay, let me turn the page. B is going to be the log base 5 of x to the 5th. And C, sorry, you can't see it. C is going to be the natural log of 12 divided by 5. All right, a couple more. Number 3 says condense using the properties of logs. Right? A is going to be 6 natural log x plus 4 natural log y. B is going to be 1/2 log base 3 of 9 plus 1/2 log base 3 of x. And then C is the natural log of 4 plus 2 natural log x plus the natural log of y. Last problem is going to say evaluate using the change of base. Okay, all right, and this one's going to have the log base 5 of 14. Alrighty, good luck with those, and I will see you tomorrow.